So proving that triangles are similar. When we want to determine whether these two polygons are similar, and again these are two triangles, we need to have two very specific ingredients, if you will. Okay, it's like kind of like when we talk about homey triangle, or I mean homey rectangle and homey square and homey rhombus. How we put a little bit of each together, and we got something out. Okay. What we need when we talk about similarity is we need a couple things, okay? So if you're in like Miss Showish class, a little bit of this, a little bit of that, okay? What we need, first of all, is to have angles that are congruent. So there is a congruency piece to this, okay? Now, do we know that the red is congruent to each other? Yeah, why? Because the angles are congruent because of what? You were given two already, and they both add up to 110. And we know, therefore, that the third angle... Thank you. We know the third angle, therefore, has to be the summation of 180 degrees because we know that a triangle, its interior angles are 180 degrees. Okay? So we have this postulate, 7.1, that says angle-angle similarity. Okay? Angle-angle similarity. And that just says that if we have any two angles of two triangles that are congruent, there's our congruency piece. Okay? Then the triangles are similar. That does not say are congruent. It says are similar. Okay? So we look at angle A, or diagram A. Are those two triangles similar? Yes, why? Because the vertical angles are congruent, good. And we have two that are given that are congruent. Good deal. Okay. B. What about B? We have a problem with B? What's the problem with B? Come on, guys. They're not similar. Why? Right, because the angles aren't congruent. We have 70, 70. And if I make this angle over here 85... Okay? Then I get 70 plus 85 plus 30, which means I get 185 degrees in a triangle. That doesn't work. Yeah, that's like a triangle that looks like this. That's a problem. It's like blown open. It's like somebody went in here, put a little bomb, went poof, blew it open. That's not good. Can't do that. Okay? Okay? So, let's look at this. Use the angle-angle postulate to complete the sentence. It says, complete the diagram. Okay? Are the two triangles similar? Well, we know that we have 90 degrees together. And this one we have 51. So if I have 90 plus 51, I get 141. So what is this angle here? 39. I can stop right there. I don't have to go any further. Because I now have 39 and 39 and these two. So I have an angle-angle postulate similarity. I don't have to go any further. And when it says explain, you can say that we have angle-angle similarity. Absolutely. Angle-angle similarity. It shows it right up there. Absolutely. I'm okay with that. I think that's a fine way of doing it. Okay? So we have angle-angle similarity. So we have this theorem 7.1. And you kind of notice that there's a general theme about these, that they kind of correspond to the congruencies that we had in triangles. Okay? So theorem 7.1 says side, angle, side similarity. We've seen side, angle, side when it comes to being congruent. Okay? If an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportionate, then the triangles are similar. So I will do my best to draw two triangles. And if they say that if these are proportionate, and the angles that is included in those sides are congruent, we can say that these two triangles are therefore similar. Okay? We also have the side, side, side similarity. Okay? If all the corresponding are proportionate. 8, 4, 4, 2, 6, 3. As long as you can write the proportions, write those ratios for all the corresponding sides, and they are all equal, we can state that we have similar triangles. Does that make sense? Is that cool? Is that kosher? Down with that? Nice. Why? Why do you want me to keep talking? So I don't go ahead. Okay. So you'd like me to just, the silky smooth sound of Mr. Beery, so that you have an opportunity to copy down the slide. I will continue to speak for you as long as I possibly can. No, I'm done. Okay, that's it. Oh, wait. Whoa. Okay. I'm running out of words to say, and I'm starting to sound like one of those guys on Discovery Channel.
Actually, NPR.
No, NPR, you would all be asleep. Click! Oh, no! Oh, agony. Okay. You know you don't have to copy all the words. Yeah, she's like, no! Freeze! Okay, cool. Thanks. Okay. Oh, just made a dot. So, let's do this one. Are the triangles similar? My suggestion is always get the triangles oriented the same, so it's easy to line up the parts. So you can either take this right here and draw it like this. Okay? So we turned it. We turned it all the way around to where here is the 90 degrees. The hypotenuse is here, so the hypotenuse on this one is 10. This is 6. And this is 8. Now, okay, I'll put it. That make you feel better? Okay. Thank you. No, you can just hand them to me. 3 out of 4. Not good. I know. If I had caught them all, I'd be impressed too. So, we now start writing our congruencies. So let's do 12 and 8. 12 is to 8. As 15 is to 10. As 9 is to 6. Now we have to sit and do a little bit of reducing to make sure that these are in true fact. So let's take this 12 over 8 and let's divide by 2. We get 6 fourths. Let's divide by 2 again. We get 3 over 2. Okay. That's about as reduced as it can get. Let's take the 15 tenths. Let's divide by 5, both top and bottom. I get 3 over 2. Okay. I got 3 over 2 now. So now I'm hoping I get 3 over 2 over here in the 9 and 6 because that means they're all congruent, which means we have similar triangles. Divide by 3, I get 3. Divide by 3 down here, I get 2. We get 3 halves for all of them. We can now state, because we have side, 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 that are all proportionate, that these are truly similar triangles. Now what about B? B, we want to show that this triangle, that's a bad color to choose, this triangle here is congruent to this triangle here. Can we do that? Please do so in your notebooks right now. I'd like you to take a moment to just do that. Remember, set up your proportions. On this occasion, my suggestion is to break them apart into 2 separate triangles so you can see them a little easier. Okay. Okay. What? No. But what I can do is I will help you break them apart. Okay. And the one is going to be LPK, LPK, and we're going to have MKN. Now instantly we can see that K is a common angle. So both of these triangles have this angle here in common. Okay? So now we know we can use side angle side, so we only need to do the two proportions. So let's look at this left side. The large triangle left side is 10. Because they're the same exact angle. That's the reflexive property. Thank you. I know. Okay. So the left side is going to be 8 is the short side to 10. Now I need, if I'm going to make this the short or small triangle and this the large triangle, I need to keep with that same pattern when I write the second similarity. Okay? So my second similarity, I'm going to look at this bottom. And the short side on this is going to be 12. And the long side is going to be 15. Nice. Now on this one, you can do it one of two ways. You can either break these down like we did last time, or you can cross multiply. My suggestion is break them down first. Then I get 8 divided by 2 is 4. 10 divided by 2 is 5. 12 divided by, let's do 3, because I can get 4 out of it. 15 divided by 3 is 5. So now I can say yes, because side, angle, side, similarity. So I can now prove that those two triangles are similar. Remember, we are not proving congruency. We are proving similarity. They're similar triangles with different proportions, larger and smaller. But they're similar, meaning that their angles are going to be the same. Who's your coach?
Can I throw something at you now?